Again, it says solve by graphing, so we're going to graph the inside, or the one side, the 3x squared minus 3 with the absolute value, and the other side is 3. Those are the two things that we're going to graph. So first of all, the blue one is the tricky one. And because it's an absolute value, what you would do is you would first graph the inside. Now, the inside 3x squared minus 3 is a parabola. Do you see that its vertex would be at 0, negative 3? And then because the a value is 1, you'd go over 1, up 3, over 1, up 3, then over 1, up 9. It'd go up very quick, very fast. You would have x-intercepts at 1, 0, and negative 1, 0. And I'm just going to draw this with a dotted line, because the dotted line is 3x squared minus 3. What's the absolute value going to do? It's going to take this part here and flip it up and make this W-looking graph. Next, in green, we're going to graph y equals 3. Can you see that there are 3 solutions? There's one here, here, and here. This one is easy to see. This one's not so easy to see. In fact, I don't know. Anybody figure out that if you've used, does that work? No. Let's see. Or maybe it does. Oh yes, it does. Square root of 2 works. And over here, you'd have negative square root of 2. I cheated because I used a little bit of algebra. Because I don't think naturally you would go on your graph and go straight down and go, oh, square root of 2. Looks like that lined up perfectly with square root of 2. That's what I would say when I look at that graph. So we're realizing we have problems with our graph. Now, for those of you that have a graphing calculator, we can figure this out with our graphing calculator. So I'll show you how to do that. For those that don't have a graphing calculator, you can also solve this by using Desmos. That's a really good app. But while we're waiting for the graphing calculator to get ready, we'll also start question B. So for B, you would want to graph y equals the absolute value of 2x squared plus 4x plus 1, and in green, y equals negative 2. Oh. It's the same question as your question 6b before. You can already see that there's going to be no answer to this whatsoever, but the question said, solve by graphing. So this is a little painful, because the green one's quite easy to graph. The green one is going to, oops. The green one's going to be right here at y equals negative 2. Can you see that the blue one is going to be a parabola where the bottom part gets flipped up? So it's going to be like that W again. Will the blue one ever hit the green one? Will they ever intersect? Absolutely not. So we know that the answer to this is no solution. But how would you graph this? 2x squared plus 4x plus 1. How would you find the vertex? Well, you could, this is good practice for your exam, complete the square. This is not bad review because you have to know how to graph parabolas for your exam. So how would you graph y equals 2x squared plus 4x plus 1? Well, we want it to look like this. If it's in that form, it's easy to graph, right? So what do we need to do? We would need to say, I need that 2 out in front. The plus 1 is okay at the end there. If I take the 2 out, I would have an x squared. And if I take the 2 out of the 4x, I'd have plus 2x. And I purposely left a space there. Because if I want this to look like something squared, remember that this 2 gives you a hint. What's the only thing that when you square it would give you a 2x? It has to be exactly x plus 1. But if I have x plus 1 squared and I multiply it out, I would need to have a plus 1 there. Which means I've added 2 to this side. So to compensate, I have to subtract 2. This is good review. So maybe the question, even though we're frustrated that we have to do all this extra work and we already know the answer, it's still good review for us. We would get a minus 1 here. So you would know that your vertex was at negative 1, negative 1. Goes over 1 up 2. Over 1 up 6. Up there. This is the dotted line. Then when you absolute value it, this part here would get flipped. Whoa. My scale. My scale is not very good. You see how that dash is really thick? And this dash is thin? I'm going to, there. Technically, that's perfectly flipped up. And this part would stay the same. So that is the correct way to graph that. And now we can say from the graph, they never intersect, so there's no solution.
Can you tell me why 1 was in positive? Is the absolute value in absolute sign?
Why?
1 was
For the
positive.
vertex?
Yeah.
Remember, your vertex is always the opposite sign of this one.
I think I was talking about the height setting again.
So like this one, the vertex will be negative 1, negative 1. And then the absolute value,
Oh yeah.
change the y value up. Okay. Now that my calculator is warmed up, we can click on it, and I'll show you a couple of things in your calculator. So if you go to y equals where you graph things, I'm just going to clear out some previous graphs. The absolute values can be found by hitting the math button and then going over to number. It's not easy to find. So hit the math button over to number, then you get absolute value, and our equation was 3x squared minus 3. So I write 3x squared minus 3. And the second equation was 3. So when you hit graph, the blue one has that W, that comes across. Finding where these two graphs intersect on your graphing calculator is by hitting the calculate button above the trace button. So I go second, trace. And number 5, I want to find out where they intersect. Now, it will find the closest one to where the cursor is. So if I want to find this one on the left, right, I push enter on the first curve. It automatically jumps to the second curve. Push enter on the second curve. It wants you to guess. Maybe here? Yay! And then it tells you 1.41, negative 1.41, which is negative square root of 2, as one of the answers. If I wanted to find the 0, 3 one, I could do it again. Second, calculate the intersection. This time I move my cursor closer to that one, enter, enter, enter. Oh, we can't find that one. That's fascinating. It skipped over the one that was really close. Graphing calculators sometimes have issues. Uh-oh. I'm going to try zooming in. And then I want to go second, trace. Where do they intersect? Number 5. Okay. I'm really close to this one. Last time it skipped over. Enter, enter, guess, enter. Sorry, I'm finding this extremely fascinating.
So it won't guess x equals 0 for some reason.
It's skipping over. And it has, you probably are not interested whatsoever, but I will tell you the mathematics that the calculator is doing and why it's not finding that answer. So what the calculator does when it tries to find a place where they intersect is they have the value for one, they have the value for the other one. And it checks it and says, one is lower than the other one. So then it checks another place, and it hopes to find one is higher than the other one. And then it says, well, if one is lower and one is higher, it's got to be in between there. And then it goes closer and closer until it finds the one that works out perfectly. What's the problem at 0, 3? It's below, it bounces off of it. It touches perfectly, but when it checks either side, oh, they're both negative. Let's just keep going. Let's just keep going. And it doesn't find that one as a result. Unless it gets super lucky and it just happens to try 0. Then the calculator will find it. That's why I zoomed in to see if I was closer to it, would it figure it out? Would it figure it out if I started my cursor? Oh my goodness.
Lots of fun.
I'm having so much fun. I just can't contain myself right now. It's messed up. It has x equals 0, but it's not a 3. Calculator's having some rounding issues. And we're recording, and now it's going to feel bad because we talked about it on YouTube. So we better just.
Texas Instruments is going.
Yeah. I better watch myself. Okay, questions for practice on this one, 5B and 7.